All right, we're on week 2 and set 1, and these are the notes for the first SWYK. So I'm going to zoom in here because the writing I did originally looked horrible, and I was messing around with different size pens. Anyway, I need you to understand, in order for a point to be a solution to an inequality, it must make the statement true. So we've got to have things like, 2 is less than or equal to 5. That kind of statement is a true statement. So that's what I mean by a true statement. So that's one way to determine. The other way, graphically, is that solutions will be in the shaded region. So if something is in the shaded region, now if it's really close to the boundary, it might be difficult to tell, and then you might have to revert back to this strategy right here, where you actually plug in numbers. So let's take a look at what we're dealing with today. So, for instance, in this first example, it says, let's take this point 3, -7, and we are going to see if it works. So we're plugging in 3 for x and -7 for y, okay? And so when I did that, 3 times 5/4, that's 15/4, right? Remember, that's 3/1, and you multiply across the top and across the bottom. And 1 can be written 4/4, so if you subtract those, you do end up getting what? 11/4? And so on the left side we have -7, on the right side we have 11/4, and that's definitely a true statement. So we would want to check this box. Now remember, these instructions say check all that apply. So this is one of those options. So we definitely want to have that one. So now we can move on to the next one. Oh, by the way, we can take a look at, graphically speaking, 3 -7. Well, remember, each one of these blocks is worth 2, so 3 would be right there, and -7 would be down here. So we're talking about a dot somewhere right close to the one I just drew. That is definitely in the shaded region, and that was an easy one to tell. Okay, so is the next one an easy one to tell? Just by looking at the graph. 3 and -7. Yeah, it is in the shaded region, so we can definitely tell that's going to check. But if we couldn't, we could always plug it in. And if we plug it in, we find out that -4 is less than or equal to 1. That's a definite true statement. So once again, we check that box. All right, so that would be another one. Okay, next on our list is part C here, and we plugged in the coordinate. Maybe we can tell by looking at it. 3's over here and -7's out here. Definitely not in the shaded region, so that would not be checked. And if you plug in 3, -7, you end up with, as you can see right here, -1 minus 2, which is -3, and -7 is not greater than -3, so that's a false statement, which agrees with the picture because the dot is not inside the shaded region. Okay, next. So you can see on my next situation here, they're asking me to do the graphing. And let me switch to red here. You can see I made the red dots a little bit too big, but that's okay. Y is less than or equal, so that's the -x minus 4. Now you'll notice that I made a solid line. Why is it solid? Because of the equal to portion. That creates that solid line. We've talked about that before. And this one is, since y is by itself, we can do the shading. We can use our best estimate there. Y is less than means shading below. So we're shading below this red line. Okay, all the y values below that line. Switching to the blue color, that's this one right here, right? And it also has the equal to, so it's solid. This one is greater than or equal to, so it's shading above. So if I go below the red line and here, we'll switch to this lavender color. That would be out here. This is the shaded region. And when you're doing the Math Excel, you'll just select the area where they overlap. So anyway, that is the solution to the system, that shaded region right over there. So you'll have to get the solid or dotted line part correct, as well as the overall shaded region. Okay, question 3 here. We've got the red line. Oops, sorry, let me lock that in place, otherwise you will not. Ooh, I did something wrong, didn't I? Did something wrong. Okay. Sorry, that sounded weird. It's got to be a dotted line, right? Because it does not have the equal to. So we've got a dotted boundary line, and man, I missed it. But you got the right idea there. Slope of 5, y-intercept of -4. It's shading below that line. Okay, keep that in mind. Switch to the green. We have a solid line there, right? Because it's got the equal to on it. And we are with a slope of 1 and a y-intercept of 3, and we are shading below that one. So below the red and below the green. So that would be this oops, yep. Okay, as long as I don't cross my red boundary line, we're good. Okay, that would be that section out there. So let's clear that off. And let's see, got one more in this particular set. So I notice you could see my work there that I decided to solve the bottom equation for y. When I did that, I added the 9x to the right side, and then I divided by 3. So it ended up being, 3x plus 4.6 repeating. Okay, we can see that it's going to be a dotted one, and it's going to be shaded above. The top one is going to be shaded below, and it's got a solid line. But I want you to notice what I highlighted here was they both have the same slope. They do have different y-intercepts. We learned in the last section that would make them inconsistent or parallel lines. Now these are shaded regions. So if you're basically looking at something that is got a slope of 3, it's a solid line, I'm just going to estimate here, and that is shading below. And then you've got the other one, which is a slope of 3, but it's got a higher y-intercept, and it is shading above. Notice that those two are going in opposite directions. Opposite directions. So what does that mean? Let's go look at the answer choices here, and then we'll be done with this SWYK. The shaded regions go in opposite directions. So what does that mean for the overall shaded region? That means they don't have any points in common. So this is our correct answer right here. No points in common. Because they shade in opposite directions. Don't get fooled by this one right here. They don't shade in opposite directions. Anyway. Oh, I think maybe I did a solid line when I should have done a dotted line for the one, but it doesn't really matter. They are parallel and they go in opposite directions. Had they been, by the way, had they been going towards each other, you would have gotten one of the A or B choices.